Alright, so we're going to do 9-4. It's called Parametric Equations. Alright. You might have done these last year on the calculator. I'm not sure. We're going to do them by hand though. So you have to eliminate a parameter. Alright, in order to do this, this is going to allow us to form a single rectangular equation. So what's going to happen now is we're going to be given two equations, and we're going to be given three variables within them, t being one of those variables. Okay. So we're going to eliminate that parameter of t, and then we're going to use some substitution, and then we're going to get down to one equation that's in rectangular form, meaning in x and y. Okay? Alright, so here are the steps. Okay, step 1, you solve for the parameter in one equation, which is normally t. Okay. Step 2, you plug that, let's say that equation, into the second equation. Well, actually it's not an equation, right? It's an expression that we're going to plug in. That's better terminology. Okay, so we're going to plug that expression into the second equation, and then you just simplify it. Okay, sound good? Questions on the steps? I'll give you these after. Ready to try some examples then? Okay, I went too fast, sorry. You're used to it? Okay, are we caught up on the steps? Ready to go for the examples? Here we go. Here comes the fun. Go ahead, Sam. I'll just write it down, and then you think about what we'll have to do. Okay, so the steps say that you have to solve for one of the parameters, which is t, and then you're going to plug it into the second equation. So we're going to substitute. Okay, so you solve and then substitute. So looking at our two choices here, our equation for x and our equation for y, which one do you think is easier to solve for t? Right, the x. So that's where we should start. So step 1, we're going to solve for t in the x equation. So we have x equals 3.2t, so that means that t is equal to x divided by 3 over 2, or 3.2. Once you have that, now we're going to take that t and we're going to substitute it in here to y. We're trying to eliminate that parameter of t. Okay? Yes? Question? Oh, okay. Alright, so y equals 4.5 times x over 3.2 squared plus 3. Okay, so we're going to square that fraction. And 4.5 times x squared over 10.24. Still plus 3. Okay, now when you distribute that 4.5, you're going to get 4.5 x squared over 10.24. But we never, in a million years, would write a decimal in a fraction, right? So you just put that in the calculator, convert it to a fraction. You can convert it on your own if you just move the decimal over 2 places to the right, and then simplify. Either way, you end up with y equals 225 over 512, x squared plus 3. Now, what's going to happen is, hopefully, once you take it into rectangular form, you're going to notice something about these equations, okay? So looking at this first one, what is this an equation of now? Whoa, what is it? It's a parabola, because there's an x squared term. One squared term creates this parabola. Okay, so this formed a parabola. Alright, so this is our answer. You eliminate the parameter t, you substitute, you simplify. Let's try another one. X equals t squared minus 4, and y equals t minus 2. Yeah. So what I did was converted it to an integer, so 450 over 1024, and then simplified. You can also just put it in the calculator. I'll simplify it for you. Okay, so looking at this one, again, you want to choose the easier equation to work with. So based on this, would you agree that we should start with y? Because we just have an exponent of 1. So t equals y plus 2 in this case. And now we substitute. So we have x equals y plus 2 squared minus 4. Now, I feel like your instinct is telling you to, distribute or FOIL this out. Anybody wanting to do that? Yeah, it's natural, right? It's what we do in math. But here, what if I wrote it like this instead? Y plus 2 squared equals x plus 4. Does that look familiar to you? Yes. What is this an equation of? So, and what kind of parabola is this? To the right, because we have a y squared term and a positive 4p, right? The 4p here is just equivalent to 1, right? Everybody agree? Remember that? Conic sections coming back at you. Still not losing them. Good thing we did that refresher project. Yes?
Yeah.
Are you with me? Sort of. Okay, so this is like a sideways parabola, points to the right. We went from a parametric equation, right, set of equations, down to this rectangular form, creating this conic section. This is in standard form, remember? So we have our squared term on the left, and then we have the rest of that on the right side. Okay.
So we're trying to find any equation?
We're trying to get into a rectangular form that we recognize. Okay, it won't always be a parabola. Okay, sometimes it will. Here, you try this one. X equals t squared and y equals t. You should be done. Are you done? Yeah, does x equal y squared? Yeah, okay. So sometimes it's really easy, okay? Sometimes not so much. Now we're going to do an example of not so much, all right? Everybody see that, again, this is a sideways parabola pointing to the right? Yes? We all recognize it. Pardon me? You could put this as y equals plus or minus root x. However, this is a form that we recognize. Okay, so we want to try to get it into standard form if possible. Okay, so let's try something a little bit more difficult because this is just getting too boring. All right. Okay, how about this one? X equals 1 over the square root of t plus 1. And y equals t over t plus 1. That looks better. More exciting. Okay, so the first thing you have to decide is which equation is easier to find t in. Hopefully we all see that it's x, right? There's only one value of t compared to y, which has two values. So that's not going to work, okay? So we're going to go with x. So the problem with x right now is that it's under the radical, right? Like, we got to get rid of that. So how can we get rid of it? Square both sides. So we're going to square both sides first. So I have x squared equals 1 over t plus 1. Uh-oh, I lost my tail there. T plus 1. Now what? How about if I wrote it like this? What can you do now? Cross multiply, right? It's just a proportion. So we have x squared times the quantity t plus 1 equals 1. Remember, we're trying to solve for t. Yep, divide by the x squared. So t plus 1 equals 1 over x squared. Now what? Subtract the 1. So now I have t equals 1 over x squared minus 1. I'm going to get a common denominator just so it looks a little bit nicer. Okay, so if I take this 1, I can just change it to x squared over x squared, giving me t equals 1 minus x squared over x squared, which is a little bit easier to work with when we're substituting. Okay, so remember, that's just like half of it. Okay, right? That's just step 1. It's just solve for t. Now we have to take that t and substitute it into y. Okay, so it's going to get a little messier. So let's do that. So we have to do two substitutions here because we have two values of t. So now I have y equals 1 minus x squared over x squared over 1 minus x squared over x squared plus 1.
So you do always put t into the equation, the other equation?
Yes, that is the goal, is to eliminate t. Okay, so now this is going to take us way back in the year, all the way to that very first chapter which you all enjoyed so much. This was one of your top topics, okay? This was one of your favorites. So we have these compound fractions. They look horrible, they look intimidating, but what do we do to make them nicer? Go ahead, Jake.
Can you change the 1 to an x squared over?
You could, so we could get a common denominator in the denominator, right? So then this would be y equals 1 minus x squared over x squared in the numerator. And then our new denominator, when we combined, our x squareds would cancel, and I would have 1 over x squared. So that already looks a lot nicer, okay? How do I get rid of this compound fraction? How do I get rid of this problem? Yeah, multiply by the reciprocal, right? Dividing by this 1 over x squared is the same as if I was to multiply by just x squared over 1. So I'm going to change this division into multiplication of the reciprocal. Now things are looking up already. The x squareds are going to cancel, everyone agree? Right? These x squareds cancel, and I'm left with y equals 1 minus x squared. Now again, I want to try to get this into a form I recognize. Okay, so we're going into that standard form. So I'm going to try to get the x squared alone, move everything else over. So this is going to give me a negative x squared equals y minus 1. But remember, in standard form, you had nothing but the squared term. So now I'm going to have to multiply both sides by a negative or divide both sides by a negative. So that should be your final answer there. I'm just putting this back into standard form. That should be my final answer. If I asked you to identify what this was, could you do it? It's a what? Parabola. Which way does it point? Down, right? Because of the negative 4p there. So this is a parabola, pointing downward. Okay? This is a more complicated problem, right? Lots of algebra going on in it. Still the same steps, though. Eliminate the t, solve for t, substitute, and then you're done. Okay, let's switch gears a little bit. Let's try something different. So far all we've done is parabolas. So let's try this one. X equals 5 cosine theta plus 1, and y equals 5 sine of theta minus 3. This looks different. Okay, so notice we have still 3 variables, right? We have x, y, and theta now. So this is a little different because before what we could do is we could solve for t in one equation and then substitute it into the next, right? But you can't do that same process here. So are there any thoughts on how I can eliminate a parameter? Yeah?
Can you do like try to find like cosine theta, like to try to like find match the cosines?
Okay, I'm not sure what you mean by match the cosines, but I think you might be on the right track.
Convert like one over the sine and the cosine to get them to like match and like cancel each other.
Okay, so yeah, the goal is to somehow eliminate sine or cosine, okay? Is there anything that we know about sine and cosine? Like, we can't like flip reciprocals, things like that with sine and cosine, but there's other things. Jamal? If I turn them into tangent, I am introducing another parameter. So I don't want to do that, but they do relate that way. Any thoughts on how I can eliminate it? This is a hard one. Yeah?
Is it equation from chapter 5?
It is.
I don't remember if it was cosine plus 1 or cosine minus 1. Cosine squared. Oh, yeah.
Cosine squared, what?
Oh, sine squared plus cosine squared equals 1.
Yes. Okay, so remember that thinking thing we used to do where I'd write down what I was thinking? This is what I'm thinking, okay? So somehow I have to relate sine and cosine. I know that they relate by sine squared of theta plus cosine squared of theta being equal to 1. Okay, so I'm going to use this. So now this is different because, see, before what we were doing is we were taking one equation, manipulating it, and then substituting it into the other. But now what's going to happen is I'm going to have to work with both of these equations and substitute it into a third. Okay? So if I just look at the equation of x, and if I solve for cosine, see, because I want to work with this third equation here. Okay, I want to work with this identity. So if I solve, I can subtract the 1. Whoopsie, not the 5. I can subtract 1. And then I can divide by 5. Everyone agree with that? Okay, so if I divide this by 5, then I get cosine of theta equals x minus 1 over 5. Okay, now what I want to do is I want to now work with the y equation. I want to get sine because I have sine squared plus cosine squared equals 1. So if I know cosine and I know sine, I can substitute them into that identity. So now I'm going to work with the y equation. I'm going to add over the 3. I'm going to divide by the 5. So now I get sine of theta equals y plus 3 over 5. Okay, so now I know sine and I know cosine. I can eliminate them by substituting them into the identity. Remember, the goal is to just get x and y. Well, when I do that, I will eliminate cosine that way, and I will eliminate sine. So if I do this, I have y plus 3 over 5 squared plus x minus 1 over 5 squared equals 1. Notice I have eliminated theta completely. Okay, so now I'm going to simplify this. So we're almost there. It's going to be like awesome at the end. So just wait. So y plus 3 squared over 25, right? Plus x minus 1 squared over 25 equals 1. Oh, you know what, you guys? I messed this up. I wanted to write down a 2 here because I just messed up this equation. But can we go back and... It's not going to be a big deal. It's not going to be a big deal. I just said it's not. Make that a 2. Don't you even think of whining. And take all those 5s and make them 2s. Otherwise, it changes the whole scenario here. 2, 2, 2, 2. When you square it, you get a 4. No big deal. Now, there's a reason why I wanted to do that. Okay? So, look at this. Look at this in the end now. Do you recognize this? It's an ellipse, right? Isn't this an equation of ellipse? 2 squared terms, both positive, different coefficients. Okay? This is an ellipse. Now, technically, we should rewrite it so that it's, x minus 1 squared over 25 plus y plus 3 squared over 4 equals 1, because that was standard form, right? Having x first and then y. And then this is an equation of an ellipse. Pretty cool. Yes? There's no subtraction, right? We're going to talk about a hyperbola. Let's go back for just a second for my mistake. When this was both 25, what would you have to do there? Wouldn't you have to multiply by 25 because they were the same? This would be set equal to 25 then. 2 positive squared terms set equal to a radius squared. It would have been a circle. Okay, so I guess we could have kept it, but I wanted to talk about the ellipse. Okay? All right, couple more, and then we're done. So now let's try this one. This one should be easier now that we kind of have this idea in mind. So x equals 3 plus 3 tangent of theta, and y equals 2 plus 5 secant of theta. Okay, so same idea again. In terms of we don't have t, so we can't just solve in one equation and then substitute into the other. But hopefully, now that we've kind of looked at example 5, something is standing out to you, and you do have to go back to chapter 5. Actually, chapter 4 we learned this in. So, thoughts? Kelly? Yep. Mm-hmm. Oh, I'm positive. I love that. Are you sure? I'm pretty sure. I'm pretty sure. No, it's 1 plus tangent squared equals secant squared. I think. I think. Okay, check it. Do you remember another one? I know. I love that. Are you sure? It's hard to say. I know. Say it louder. The other thing I want you to be thinking about, maybe just make a note of it so that way you can be sure later on, is 1 plus cotangent squared is equal to cosecant squared. You need those Pythagorean identities for these parametric equations, okay? Just those three. Just those three, okay? Now that we have that all clarified, okay, do you see what we're going to do here again? Right? We're going to solve for tangent. We're going to solve for secant. We're going to plug it into the identity so that way you can get a rectangular equation of just x and y. So that's what we should do. So x minus 3 equals 3 times tangent, right? So then that must mean that tangent of theta is x minus 3 over 3. Solving for y, we get y minus 2 equals 5 secant of theta divided by 5, and we get the secant of theta equals y minus 2 divided by 5. So you're just simplifying or, kind of manipulating that equation in order to solve for tangent and secant. Once you know those, you're ready to plug it into the identity to eliminate that parameter. So now we have 1 plus x minus 3 over 3 squared equals y minus 2 over 5, that quantity squared, okay? Again, don't FOIL it out, right, because we're going to standard form, and we don't do that in standard form. Just keep it as that binomial squared. So we're going to have 1 plus x minus 3 squared over 9 equals y minus 2 squared over 25. Do you recognize this in standard form? Is this in standard form? Can you recognize the conic section we're talking about? No. So what do we have to do? Subtract over that x term, so I'm going to have y minus 2 squared over 25 minus x minus 3 squared over 9 equals 1. And now, what is this an equation of? A hyperbola. In what direction? Is it horizontal or vertical? It's vertical. Okay, pretty cool. Isn't this fun? I mean, it's not bad, right? Simple algebra. Refresh those algebras. Yeah, I see some shoulder shakes, some maybes. You are having fun. I know it. I can see it in your eyes. Don't try to deny it. Yes. Yes. Whatever term is positive, that's what has to come first. Okay? This is going to be our last one. It's going to be super exciting. Trip down memory lane. Isn't this fun? It's like going back in the year, just kind of reminiscing about some of the fun we've had. It is easy. You just got to refresh some skills. That's all. Any thoughts on this one? Run, hide, cry. Right? This was what you hated. You hated this. Well, do you see that t is back? Okay, so t is back. So the goal would be to get t by itself and then substitute. So that is our goal. Anyone remember how to do it? Yeah, we're going to have to introduce a log. Yeah, remember the path? Yeah, we got to change it, right? So right now, it's in exponential form. We need to take this to log form. Keep in mind that e translated into natural log, right? Log base e. Remember that? Okay, so that's what we're going to do. We're going to take our x equation and we're going to convert it to log form. So we have x equals e to the negative t. Remember, you could follow that path. So, was it? We always wrote it on the other side. I always hate remembering how to write it. No, I always, you know, like, do you write the e, the little path? Yeah, I'm fine. So, remember me, okay? I like to write log base e first because it just helps me to remember, okay? So, log base e of x equals negative t. So now, I'm going to change this log base e to natural log of x because we don't write log base e. T is still not by itself, so what do I need to do? Just divide by negative or multiply by a negative 1. So t equals negative natural log of x. Are you with me? Okay.
So you come up from the x and go around?
Yeah, remember we used to write it so that it was like this. Yeah, we just wrote it backwards. That's why I was trying to picture it. All right, so now we know what t is. We're going to substitute it back in. Okay, so I have y equals e to the 2 times the natural log of x. Now, if you multiplied these together, you would have e to the negative 2 natural log of x. Do you remember what you could do with a number that was out front of a log? Yep, you can pull it over as an exponent. Remember that? This coefficient becomes an exponent in the rules of logs. Okay, so this is really like y equals e to the natural log of x to the negative 2. And then does anybody remember the property that's going on here? E and natural log, what happens to them? They cancel, right? When you had a base and that log to the same base, they would cancel each other out because this is like log base e. We might need to go back and refresh those properties. You can go back and watch a video on YouTube. I think it's like less than 3.3, okay? Somewhere in there. So y equals x to the negative 2. Now, we wouldn't write that, you know, as a negative exponent. So if you wanted to change that to a positive, you'd have 1 over x squared. Okay? So this is the only one that students are like, I don't really know about that one. It's because you just don't remember the properties. Okay? So you might need to refresh some of those properties of logs. But everything else is pretty straightforward. Yeah,
Like for the t, could you do like the natural log of x raised to like the negative 1?
you could.
Okay.
Yeah, you could.
Or would it not make a difference?
It wouldn't make a difference. If you plug this in as x to the negative 1 here, you could still pull over the 2, giving you negative 2 still. Yep. Okay? And then this is really just parametric equations.